Welcome back to Math 104. Let's look at a new application of Pascal's triangle to finding probabilities. This application requires a little bit more careful thought. According to a simplified model, a certain stock either goes up $1, represented by the letter U, or down $1, the letter D, each day, and is equally likely to go up or down each day. We mentioned this experiment once before, just as an example, one among many, of experiments where the outcomes can be represented as words in a two-letter alphabet. Here the letters are U and D. Let's see how this goes. What is the probability that by the end of 4 days, the stock has had a net increase in value? Before we do anything else, our immediate response to hearing the phrase, the end of 4 days, which means that we're running our experiment through 4 stages of observing ups and downs, our first response is to write the fourth row of Pascal's triangle. Now we ask, which outcomes contribute to the event that there is a net increase in value? Here we have 0 U's and 4 D's. Here we've got 1 U and 3 D's, 2 U's and 2 D's, 3 U's and 1 D, and finally 4 U's and 0 D's. It is precisely these outcomes where the number of U's exceeds the number of D's, where there are more ups than downs. That's what it means that there is a net increase in value. So we have to stop and think a little bit what the words mean in terms of number of U's and number of D's. The probability in question equals 5/16. We go on to ask, what is the probability that by the end of 4 days the stock has had no net change? Let's write a fresh copy of row 4 of Pascal's triangle. No net change means that the number of U's equals the number of D's. The number of ups equals the number of downs, and therefore they exactly cancel one another out. Thus the only outcomes in our event are these 6. Therefore the probability of 2 U's and 2 D's, we can write it this way, equals 6/16. Notice that this is equivalent to asking, what is the probability that on 4 flips of a fair coin, the number of heads equals the number of tails? What is the probability that over the course of 5 days the stock has a net increase in value? And how can you rephrase this question in terms of coin flipping? I hope this is starting to become a habit for you, that you write down, in this case, the 5th row of Pascal's triangle. As soon as you see that this is an experiment with 5 stages, with 2 possibilities at every stage, it is a job for row 5 of Pascal's triangle. We are counting up from 0 U's and now 5 D's, all the way up to 5 U's and 0 D's at the other end. And we want to think about which outcomes contribute to our event that the stock has a net increase in value. Now notice, here we have 1 U, 4 D's, 2 U's, 3 D's, 3 U's, 2 D's, 4 U's, 1 D. In order to have a net increase in value, the number of ups should be strictly greater than the number of downs. That means that any of these outcomes contribute. The probability, therefore, is 16/32, which is just 1/2. In the next problem, we're asked for the probability that over the course of 5 days, the stock has a net decrease of more than $1. When there are 2 ups and 3 downs in whatever order, there is a net decrease of $1, exactly $1. So these 10 outcomes do not contribute to our event here that the net decrease is more than $1. This is a net decrease of only $1. These are net increases, so they don't contribute either. We are left with only these 5 outcomes, which have a net decrease of $3, together with this one outcome, which has a net decrease of $5. Thus we need only these 6 outcomes, and the probability is 6/32. We can ask, what is the probability that by the end of 8 days the stock has had no net change? And it would be a fine thing to write out all of row 8 of Pascal's triangle. We might think about this for a moment, though, and realize we're really only looking for one entry in row 8, the one entry where the number of U's equals the number of D's. In our notation, that's 8 choose 4 divided by the total number of different possible outcomes, which is 2 to the 8th. And that's interesting, we've actually computed this before. This is 70 over 256. This is the same probability we computed for obtaining an equal number of heads and tails on 8 flips of a fair coin. Mathematically, that question about equal numbers of heads and tails and this question about no net change are equivalent. What is the probability that by the end of 8 days the stock has had a net change in either direction of at most $2? This is another one of those questions where we have to stop and think a little bit. Here it is a good idea to write out all of row 8 of Pascal's triangle to help us sort out exactly which outcomes are really in this event. I encourage you to pause the video at this point and try to do this one on your own. This middle entry corresponds to having 4 ups and 4 downs. The ups and the downs exactly cancel one another out, and that corresponds to a change of $0. A change of $0 does count in this event. A change of at most 2 means 2 or less. So a change of $0 is in this event. These 56 outcomes are the number of ways of obtaining 5 ups and 3 downs. That would give a net gain of $2, and a net gain of exactly $2 does count towards this event. Similarly here, these 56 outcomes are all the ways to obtain 3 ups and 5 downs in whatever order. That is a net loss of exactly $2. You gain $3, but you lose $5. That's a net loss of $2. And that, too, is in the event that we're asking about. All the other changes are either gains of more than $2 or losses of more than $2, and therefore do not contribute toward this event. So the outcomes we need are exactly these, the middle 3 numbers added up and divided by 128. Just to practice notation, what we're computing is 8 choose 3 plus 8 choose 4 plus 8 choose 5. That's just identifying these 3 values in row 8, all divided by 2 to the 8th. That turns out to equal 182 divided by 256, and that's about 0.7109. This is quite a substantial probability. These are only the middle 3 entries of the row, and by this phenomenon of clustering about the middle, they account for 71% of the probability. How can you rephrase this question in terms of coin flipping? What we've just computed could also be described as the probability of flipping a fair coin 8 times and obtaining 3, 4, or 5 heads. Or you could phrase it in a similar way to what we have written here. What is the probability that on 8 flips of a fair coin, the difference between the number of heads and the number of tails is at most 2?